Hi, welcome to today's lesson. Today we're going to be talking about special right triangles. Let's now talk about special triangles and exact values. Our first special triangle is the 45, 45, 90 triangle. Of course, I've got 90, 90, 90, and in each case I've got 45, 45, 45. That means I've got an isosceles triangle. You remember from geometry that the angles across from my 45 degrees will be, the sides across from my 45 degree angles will be congruent. Well, if I have the general case, whatever I have here, if I have x here and x here, because we have an isosceles triangle, I'll have x square root of 2 here. That's probably the most important one to remember. Well, what if x was 1? That would mean this is 1 and this is 1, and I have 1 times the square root of 2 here. That one's not so important to remember. What is important to remember is this. What if I made, instead of making my hypotenuse x squared root of 2, what if I forced my hypotenuse to be 1, as we do in something called the unit circle? Well, if 1 is equal to, if 1 is x squared root of 2, x square root of 2, I can now solve for x. I can divide both sides by the square root of 2, and I wind up with x is equal to 1 over the square root of 2, which I have to rationalize. I can't leave radical in the denominator. So I multiply both numerator and denominator by the square root of 2. So x must equal the square root of 2 divided by the square root of 4, which is 2. If that's the case, then my x and my x are 2 over, square root of 2 over 2, and the square root of 2 over 2. These are the most important triangles to remember. In general, it goes x, x, x square root of 2. You have to know that triangle. It also, if you take your x squared root of 2 and you force it to be 1, then you can solve for x. And when you solve for x, you get square root of 2 over 2. Square root of 2 over 2. Again, we have this isosceles triangle. You have to memorize this triangle, and you have to memorize that triangle. In our second special triangle, we have something called a 30, 60, 90 special triangle. Again, we have 90 degrees, so obviously opposite our 90 degree angle, we have our hypotenuse. Opposite the 30 degree angle, we're always going to have x. Opposite the 60 degree angle, we're going to have x square roots of 3. And opposite the right triangle, we'll have 2x. x squared root of 3, 2x. So if x is 1, across from 30 we'd have 1, across from 60 we have 1 times the square root of 3, or just the square root of 3, and across from the 90 degree angle we have 2 times 1, which is 2. In a unit circle we always force the hypotenuse to be 1. So if I force this to be 1, then my 2x is going to equal 1. If 2x equals 1, I can divide both sides by 2, and I get x is equal to 1/2. Well, where does x come into play? It's across from the 30 degrees. So across from 30 degrees we get 1/2. Across from 60 we have x times the square root of 3. So if x is 1/2, we have 1/2 times the square root of 3, or square root of 3 over 2. You have to memorize these two triangles. The general case, across from 30, x, across from 60, x squared root of 3, across from 90, 2x. When the hypotenuse is 1, sometimes it's forced to be 1, as in a unit circle, we go 1/2 across from 30, square root of 3 over 2 across from 60, and 1 for the hypotenuse. If you can memorize these two, your life is going to be so much easier when they ask for something called exact values. For exact values, you're going to have to use one of these two triangles, 45, 45, 90, or 30, 60, 90. These two triangles that you have to memorize are so important, these special cases, that I wanted to show it to you one more time. 45, 45, 90 goes x, x, x squared root of 2, which can be converted. If you force the hypotenuse to be 1, then it becomes square root of 2 over 2 square root of 2, 1. Notice with these is an isosceles triangle. The legs are equal. The 30, 60, 90 triangle goes x squared root of 3, 2x. When converted, forcing the hypotenuse to be 1, our ratios become 1. Across from 30 is 1/2, and across from 60 is square root of 3 over 2. Please memorize these. Here are some easy problems involving trig ratios. For example, it says here, find x in each of the following triangles. Well, they give me 40 degrees. I know that this is a right angle here. It also gives me that. So my hypotenuse is 3.5 and my x is unknown. Well, if I take adjacent over hypotenuse, I'm talking about cosine. So I can say cosine of 40 degrees is equal to adjacent to 40 is x divided by 3.5. Well, if I have that, I can now solve for x by multiplying both sides of the equation by 3.5. So x is equal to 3.5 times cosine 40 degrees. As long as my calculator is in degrees, I'll get, when I mash this out to 3 sig figs, is 3.68 what? Centimeters. So centimeters. Why? Because we just found the side. In this triangle, I'm given that this angle here is 60 degrees. The side opposite is 8.2. This is the hypotenuse here because it's across from the 90-degree angle. So I only know the opposite and the adjacent to 60 degrees. Compared to 60 degrees, this is opposite and this is adjacent. Well, that ratio is tangent. Tangent of 60 degrees is equal to the opposite, which is 8.2 centimeters divided by x. I'm going to solve for x. So first I'm going to multiply both sides by x, so I get x tangent 60 is equal to 8.2, and then I divide both sides by tangent 60, so I get 8.2 divided by tangent 60. Make sure your calculator is in degrees, and finally you'll get x is equal to 4.73. It's a side, so that's centimeters to 3 sig figs. In this last problem here, I'm asked to find x, and again I'm given that this is 20, and I know that my hypotenuse is 10. Well, across from my 20 and 10 for the hypotenuse, opposite and hypotenuse, I should be thinking sine. Sine of 20 degrees is equal to the opposite, which is x over 10. So multiply both sides by 10, I'll get 10 sine 20 degrees is equal to x. So x is equal to, when you mash this out in your calculator, you get 3.42, what? Centimeters. Because we're finding the side to 3 sig figs.